if you're wondering why these videos cut out unexpectedly sometimes and then come back in a follow-up video, it's because the screencast recording software that I'm using has a video limit of 15 minutes, and so sometimes that catches up to me. Anyway, let's finish up with talking about mean, median, and mode. I think we handled mode, mid-range. Let's look at the next thing in the Triola book, which is example 5 on page 84. Mid-range is pretty simple. It's just the number of scores, values between the minimum and the maximum. Right, so don't follow my cursor for the moment. Let's write out the facts that we know from this distribution, and this is where sorting it helps again. The maximum is 98, and the minimum is 2, and the solution is just F18 over F19. Oops. Right. Sorry, I was thinking back to, we could have written this by saying C16 over, or minus C2, but I did it by writing them here first and then doing the formula from there. So then I started to wonder, because these aren't Excel formulas I've used before, is there a max and a minimum formula? Well, it turns out there's a max formula. And really what I wanted to know first is there a mid-range formula? Well, I tried equals mid, and no, that doesn't look right. Mid-range, didn't see anything. Range, because remember it'll type in, oops, not range. It'll show you formulas with that spelling as you start to type it out. So I didn't see anything, and this wasn't a situation where I thought looking up online was going to be helpful. So I did want to show you, though, that there's a max and a minimum. I made a note there to copy this. Now notice what happens. Copying can get you a little bit confused sometimes when you're doing formulas. So remember that when I've got a formula, let me zoom out on this just a little bit. When I've got a formula and I go into it, it highlights the set of observations that's selected, and it matches the color here that's in the cell. And if I wanted to do another range, for example, this won't make sense with this formula, but let's see. If I wanted to do C2 through through C16, you don't have to capitalize these either. Excel will always change it to caps, but you can type them in as lowercase. See, it's using green now, and it's highlighting that one in green. So that can be pretty helpful. But right now we're just dealing with this one, B2 through B16, fine. But when I copy it, well, what happened? The number looks right, but now look at where that blue rectangle is over here. It's actually doing, or look right here, it's doing B3 through B17, because I moved it, and remember I showed you in another video that when you move it horizontally, it sort of follows your logic, and it takes the next cell, next column over from the one that you copied it from. So in this case, it's doing the same thing when I copy vertically. It's thinking that, well, now the observations he wants must be one cell down because he's copied it one cell down, and that's not true. Just as another side note, if I wanted to fix that, like if I want to do a lot of copying and pasting of the formula, I can come in and I can put $ before, oops, not before that, before the cells that I want to fix. So if I want to fix B2 and B16, I would do that. And then when I move it, it won't change, and it'll still be B2 and B16. Right? But in this case, I actually want to do a completely different formula, so that's great. So I still want that range, and I want to just show you that there's a minimum formula too. And these aren't case sensitive either, but Excel will always give you it always just capitalize it when it processes it. So that gives us the same thing too, there. And so we could do this guy again by just doing G18 minus G19. I'm going to try to talk pretty quickly about standard deviation and variance. Well, more quickly about variance. Triola doesn't show this as a formula. It doesn't look like it right around page 97, 98, where he talks about standard deviation. And that may be because we have a different use of variance later on, and he may be saving that concept. But the standard deviation and the variance are pretty closely related. So I wanted to talk about it just briefly. And the way that they're related is that the variance is the square of the standard deviation. And then, so conversely, the standard deviation, let me make this a little bit wider, is a square root of the variance. And so you'll see that in the standard deviation formulas that you see, formula 3, 4, and 3, 5, on page 97. They both take square roots of this relatively complex calculation, and that within that calculation is the variance. There's a couple of different kinds of variance, and we'll deal with something called sampling variance later when we talk about statistical testing, but right now we're just talking about a more basic type. So that's how these two things relate. Okay, I've added some things to this spreadsheet to make it a little bit easier to walk through it rather than setting it all up at the same time. So we're talking about standard deviations and variances, and I just explained to you how a variance and standard deviation relate to each other. So let's try using formula 3-4 on page 97 to calculate the standard deviation for the distribution that we've come up with here. I copied the x-fixed distribution from above down below, and like we've done before, let's lay out the things that we need for this formula. So we need x bar, right? This is, if you look at this formula 3-4, it's saying that under the radical, it's the sum of the quantity x minus x bar squared over n minus 1. And so we need x bar for part of that. The next thing we need is that whole numerator piece, the sum of x minus x bar squared, or the sum of squares. We need n. Actually, I don't need n in this one, but we do need n minus 1, so I guess we need n in a roundabout way. And the way that I've set this up is to first do the variance calculation and then just take the square root in the last step. And I find that easier because it's just easier to look at this one piece and where I may have made a mistake than it is to sort of wrap it all up together for me. We could wrap it all up together in one formula here that started square root and then parentheses and another set of parentheses and this piece in the numerator divided by another set of parentheses and piece in the numerator or the denominator. But I like to do it piece by piece. So let me show you what's going on here. So that numerator piece, the sum of squares, comes from the distribution we've got there, and if you notice it says x minus x bar. So here's one value of x, and our x bar is over here, and I just copied this down from H2. You can see we calculated that earlier. But to get the x minus x bar squared part, I wrote a little formula here, B23 minus G30 with the dollar signs squared. So B23 is our value of x, G30 is the mean, and then the caret to square it. One of the mistakes that people will make here is they'll do sum of the x minus x bar. They'll just do this little piece and then sum everything and then try to square it. And what you need to do is you need to square it at the same step. So one thing that sometimes I'll do, and if you're practicing this, I'd recommend doing this, is to do it in multiple steps. So do the B3 minus G30 part, and you'll have a column for that, and then do this where you just square it, and again, it just helps you walk through the steps a little bit better. But I've done those both all in one piece. And so for each value, we've got a square square deviation, x minus x bar squared. Why square it? Just to get rid of any negative signs. Some will be above the mean, some will be below the mean. To get rid of the negatives, we can square it. Okay, so for formula 3, 4, that's the only thing we need. And we can start putting the pieces together. So let's go and do everything that's under the, or actually show you where I put this first. I could have summed and put it down here, but I put it over here. Sum of C23 through C37. So this is that quantity in the numerator, sum of x minus x bar squared. Then when we want to go calculate what's under the radical, all we need to do is do G31, sum of the x minus x bar squared, sum of the squared deviations, and divide by G33, n minus 1. And then when we want to actually finish this and get the standard deviation, we just take the square root of G34. Triola gives you a second formula, and he says that this formula is easier for doing hand calculations, doing it by calculator. I agree. I've never really used it myself, for homework and things. I actually kind of like the first formula because it is more intuitive. It's just easier to remember. So if I were quizzed on how to calculate a standard deviation, I would think of formula 3-4 first, but you could use either one. We need a different piece of information here. I'll zoom out again so you can see them both together. For 3, 5, we need, and again, we need the sum of the x squareds, and then we need the sum of x, that quantity, squared. Again, pay attention to the parentheses so you know what's getting squared where. We need n minus 1 again, and we're going to calculate the variance and then the standard deviation. And you can already see that we get the same result in both places. But the thing we need to do over here is to do the x's squared. So this column just has each x value, B23, through the last one, B37, squared. And to sum that, we just do sum D, we're in column D here, D23 through D37. So that's how we get the sum of the x squareds. The next one is the sum of x squared. So that's the sum of the x's, B23 through B37, and then square it. So sum B23 through B37, and then square it. Then you've got your n minus 1, and you can put this all together, just like in the formula, with n, G38 times G39, sum of the x squareds, minus G40, sum of the x quantity squared, over n times n minus 1. Gets the same result. And like I said, either of these would be acceptable on a quiz or homework, and you might find one easier to use or work with. But the one that really, I think, tells you what's going on with the standard deviation is 3, 4. It's telling you that you're taking these deviations from the mean, you're squaring them just to get rid of the negative, but then you're taking an average, and you've seen averages before. So it's sort of telling you that what the standard deviation is, which is the average deviation of values across the district. I hope that helps.